Everyone, today we are going to learn 5.2 double integrals in general regions. So we learned how to integrate the rectangular regions last time. So let's take a look. So general regions. So we have a rectangle, and then inside we have a bounded region, D. So they talked bounded region. They're using just a D, all right? Okay, so we have a point inside, and then let's this point as a function, g of xy, same as the f of xy, right? Then outside the bounded region, which is in the rectangular region, there's a point. So we set up g of xy equal to 0, right? So here is a two piecewise function. Then g of xy equal to f of xy. We just say that, right? This one. And then g of xy equal to 0 outside of bounded region. Then we cannot do anything about this one because it's 0, right? So we are going to integrate, find the volume. So bounded region in D in that case. Yeah. All right. Now we have a definition. So region D in the XY plane. So we have a surface. We cut off XY plane, right? And if we are using type 1 method, that is two vertical lines. Then vertical distance, vertical lines. Here is a picture. So this is a type 1 regions, the bounded region, not the rectangular general region, right? Okay, since we have vertical distance, there will be height, right? So we are using the integrate respect to y first, yeah, up and down, height, right? Then we do integrate respect x later. Make sense? Okay, so we have a type 2 region. Then we say the horizontal lines, horizontal distance. Then let's take a look at the picture. This is the horizontal distance, right? So we are using integrate respect to x first, then later y. Make sense? Okay, so we had a Fubini's theorem last time. So does it here. So integrate to dy means we do integrate to respect to y first, then x later, right? We have integrate dx, that means integrate respect to x first, then y later, right? So in here, we denote type 1 method, which is a vertical distance, and type 2, did I say type 2 error? Sorry, I confused with the statistic terminology. Type 1 method, right? Did I say that right? Type 1 method, type 2 method, right? So type 2 method is horizontal distance. Okay, so we have example here. So evaluate, we have a function, and then given information where xy, y is between -2 and 3, and the function x equal to between y squared minus 3 and y plus 3, right? Okay, let's take a look. I wrote down tip. If we have this kind of given information from the surface, we cut xy plane, right? Okay, now this is a function, right? So it's better we do the integrate with respect to x first, and then later we substitute the number, then we can get the volume easily, right? If we want to do that y first, then we have to change that, yeah, as a function. So since look, this is a vertical distance, vertical lines, right? So it's better we do integrate x first, then y later. Yeah, make sense? Okay, so that we don't have to do extra work. So let's do this one. So we have 3x squared plus y squared, and then integrate to respect to x first. So dx, then x equal to, so we have to set it up, right? So left will be y squared minus 3. Lower bound, upper bound will be y plus 3. Okay, now, then we do integrate with respect to y. Then given information, y is between -2 and 3, right? So lower bound will be -2, upper bound will be 3. Yeah. Okay. Now let's do integrate respect x first. Okay, y equal to -2, y equal to 3. All right. So integrate to respect to x. So we will have 3x to the third power over 3, right? Then second term, we do integrate to respect to x. Then we treat y as constant. So that will be plus xy squared. We keep the constant, right? And then we do evaluate from x from the left to the right. So x equal to y squared minus 3, lower bound, and then upper bound, or lower limit, upper limit, right? Okay, now let's substitute. So we have x cubed plus xy squared. So that will be, let's see, y plus 3 to the third power plus y plus 3 to the y squared minus we have y squared minus 3 to the third power and minus y plus 3, right? And y squared there. A little bit smaller. Y squared. Then dy, yeah? So let's just simplify it. We have y equal to -2, y equal to 2. This one, let's just leave like this. We can integrate easily later. So y plus 3 to the third power. Let's distribute. So we have y to the third power plus 3y squared minus this one. We have a minus b to the third power, which is a cubed minus 3a squared b plus 3a squared b, I'm sorry, b, ab squared, right? ab squared minus b squared, right? Okay. Ooh. So that will be in the negative, yeah? So let's make a bracket. A squared, which is y squared to the fourth power minus, wait a minute, a to the third power, not the second power, sorry about that, sixth power then, y to y squared to the third power, which is 6, yeah? All right, then negative 9y squared, 3a squared b, right? Okay, now 3ab squared, 3ab squared, so it's 9y. Hold on one second. Yeah, there is a mistake, right? So once again, negative 3a squared, so y to the fourth power, and b, so it's 9, right? Okay, so what about the third term? 3 times 8 times b squared, so 3 squared is 27 y squared. And then the last one is minus b to the third power, right? So there will be minus the 27. Okay, let's do this one. Let's distribute. So we have plus minus minus y to the third power and plus 3 negative, sorry, negative also 3y squared, right? Make a lot of money. Then dy. Okay, let me make a little bit orange. Minus y to the third minus 3y squared dy. Okay, let's combine like term. So we have, oh, I made a mistake here too. So this should be 3, right? Copy wrong. So 3, 3. Okay, so we have y equal to negative 2 to y equal to 3. The first term, we can integrate later easily. Okay, 6 power. So 6 power itself, right? So we have a negative y to the 6th power. And the next one is the third power. So we have a positive y to the third. And negative is positive. So 2y to the third. That's it. Okay. So positive 2 y to the third power. Second power, let's do that. Positive 3y squared. And positive negative 27y squared. And negative is positive 3y squared, right? So we have a 6y squared, negative 27y squared. We will have a negative 21y squared. right? Okay, the constant term, negative is positive 27. And we have dy, right? All right. Integrate with respect to y. So we will get this term. We have y plus 3 to the fourth power over 4 minus y to the 7th power over 7 plus 2y to the fourth power over 4 minus 21 y to the third power over 3 plus 27y. And then we do evaluate from y equal to negative 2 to y equal to 3, right? Okay, so there will be, let's do that, 3 plus 3 to the fourth power over 4 minus 3 to the 7th power over 7 plus 1 half y to the, oh no, y, 3 to the fourth power minus 7, 3 to the third power plus 27 times 3, yeah? Minus negative 2, right? So we have a negative 2 plus 3 to the fourth power over 4 minus negative 2 to the 7th power over 7 and plus 1 half negative 2 to the fourth power minus 7 negative 2 to the third plus 27 negative 2. Yep. Okay. Can you please calculate? So book has 2,375 over 7. So if I make a mistake, please let me know. And also you can extend this one too, right? So either way, like earlier, by using the formula, right? So a plus b to the quantity third power, right? So we have a positive, everything, since positive. But this is more steps, so I just keep that, yeah? Okay, so we have this example, evaluate double integration, x squared e to the xy dA, right? So we have a region D. So we have a surface x squared e to the xy. Then we want to take out xy plane region. So this is shown figure 5.16. So that region D come from x is between 0 and 2, y is between 1 half x and 1, right? So here is the xy plane. So y equal to 1, so horizontal line, y equal to 1 half x, that's straight line, right? So we can notice that there is a vertical distance. So we can use a type 1 method, right? And also looking at this one, I gave you a tip. This is number. So when you find the number, I mean, when you find the volume, number should be the end, right? So we do integrate with respect to y first, because this is the function wise. And then the later we do integrate with respect to x so that we can find the volume easily, right? All right, let's do it. So we want to integrate this surface, integrate to respect to y first. That means we treat x as a constant, right? So what we get? So that will be x equal to 0 to x equal to 2. X is constant, so we keep that constant, x squared, e to the xy. We do integrate respect to y, right? Then this is a constant, so we keep that constant by chain rule, right? So which is x, right? Okay, so I wrote down note from the calculus 1 and 2, right? So we do integrate e to the 2x dx. Then we have to have a channel, right? So since the 2 is not there, we divide by 2, right? Okay, so x is the constant. So that will be over x plus c. But then we do evaluate from y equal to 1/2 x to the y equal to 1. Yeah, is okay? All right, now let's simplify. So we will have integrate x equal to 0 to 2. Then we have x e to the xy, y equal to 1/2 x, y equal to 1. Then evaluate into y, right? So x e to the x, 1/2 x minus x e to the x itself, right? So dx. Okay, so there will be x to from 0 to 2. Then we have x e to the x squared over 2. Wait a minute, 1 minus, yeah, I'm so crazy today, right? We have to evaluate 1 minus this, yeah? So should be reverse. So let's reverse. Crazy today. Let me change. Okay, so I rearrange. So substitute y equal to 1 first, then y equal to 1/2 x there, right? Okay, so we can integrate term by term. So I label 1 and 2. So we can do that x equal to 0 to 2 minus x equal to 0 to 2, right? Okay, why I am split? Because the first one, we have to use integration by part. Second one, we can just use substitution, right? So let's do it. So integration by part, IBP. All right, so we have the formula, right? So integral of u dv minus equal to, sorry, uh, integral u dv equal to uv minus integral of v du, right? All right, okay. So then we have x e to the x power dx, yeah? Then we can notice that this is u, this is dv, yeah? All right, then we have u, what's the derivative du, which is 1 times dx, yeah? Okay, very good. What about we have dv? How do you find the v, right? So we have dv, then we do integrate of dv, then to get v, right? So that will be e to the x power dx, that's the dv, right? Then we have e to the x plus c, yeah? Okay. Then let's go back here. There will be uv, that is u, which is x, v, which is e to the x power minus integral of v du. V is e to the x power, right? Du will be dx. All right. Then there will be x, e to the x. What is the integral of e to the x? Just e to the x power, right? So minus e to the x. Let's see. Okay. That is the first term. Yeah. So we will get x times e to the x minus e to the x. What about the second term? Second term, let's do it. So second term, we can use substitution. Easier, right? Okay, so what do you want to set up as a u? Let u equal to is e or x squared over 2? Yes, x squared over 2. Very good. Okay, what's the derivative? Then we keep the constant, drop the power, so 2x. Yeah. Okay, that will be x then. All right. Then we have e to the, I did not put the dx on, dx. So we have x e to the x squared over 2 dx. Yeah. All right. Then we can express x dx will be du, right? And e to the x squared over 2 will be just u, right? Integral of e to the u du, which is e to the u plus c, right? What was the u? U was e to the second power over 2. Let's see, yeah. So there will be second term. Okay, so there will be minus e to the x squared over 2. And then we need to evaluate from x equal to 0 to 2. So that will be 2e to the 2 minus e to the 2 minus e to the 2 squared over 2 minus, first term is 0 minus e to the 0 minus e to the 0 over 2, which is 0, right? So what do you get? Do you get the 2? So 2e to the 2 minus e to the 2 minus e to the 2. So that's the 0, right? Everything's 0. Minus minus plus e to the 0 minus minus plus e to the 0. So that is the 2. Yeah. All right. Okay, so we have this question. This will be the last question for this section. So reverse the order and evaluate over this. Okay, so this order has integrate with respect to y first, then with the integrate with respect to x later, right? Okay, we have to change everything. So this one, if we are drawing XY plane, x-axis, y-axis, right? Okay, so y equal to 0 horizontal line, we know that y equal to 0. Now, 2 minus x squared is parabola open downward because negative, and then y-intercept when equal to 2, right? So let's make this is a 2, and ooh, like this, yeah? Ugly? Okay, let me try one more time. Better? Okay, so y equal to 2 minus x squared. So y-intercept, which is 2 here, and then this is 0, right? All right, so this is vertical distance, right? Vertical distance. Okay, now they ask us change in order, right? So then we have to make a horizontal distance. So that will be we have y equal to 2 minus x squared. Okay, so solve for x. So we move to the x squared other side, and y is the other side, so 2 minus y, right? Okay, then x equal to plus minus 2, square root of 2 minus y, right? Okay, now we take only the positive because it's a quadrant 1, right? So take since quadrant 1. Okay, so that will be, we get the same shape. So x equal to square root of 2 minus y. And then we set up the limit, right? Uh, so we had earlier um, x interval from 0 to square root of 2, right? Square root of, so square root of 2 there, right? And then we had y equal to from 0 to, the function is 2 minus x squared, yeah? Now we change it up, but still same shape. But then we have to change the order. We had, this is also 0 to 2. Yeah. And then also x interval will be x and y. Here is also square root of 2, right? But then let's take a look this way. When x equal to 0, we had that earlier, right? Then x equal to 0 equal to square root of 2 minus y. Then what's the y will be? Y will be 2, right? So y is the 2. When x equal to square root of 2, we had earlier, right? Then we can find out what square root of 2 equal to square root 2 minus y. Then y will be 0, right? Make sense? Okay, so we can find the limit because we are going to use the horizontal distance here, right? So reverse order, let's do it. I need to see that. So we will change that. Y equal to 0 to 2. But simply we can use here too, right? Yeah. But this is more detail. How we get that? All right, now X equal to from 0 to x equal to 0 to and square root 2 minus y, right? Yeah. 0 to square root 2 minus y. And then x e to the x, the x first, then dy, right? We change that. Okay. I think we did that, this one earlier, this way. Yeah. Okay. Now, let's do it. Am I copyright? Okay. So we do integrate with respect to x first. Do first. Then treat. There is no y, so let's do it. Uh-huh. Hold on 1 second. I did not copyright. All right. That's why I'm asking. We have a square, right? Yeah. Otherwise, we do IBP again, right? So we don't want that. Squared. Then we can use substitution, right? All right. So please watch this method in my YouTube video. So let u equal to that. We can just simply do that. X squared we have to have, right? Then, hold on. Let me do for you. So let's do it. But if you're using this method, it's very easy. Try to do. Okay, so let's using your substitution. Okay, what do you want to set up as a u? X squared? Good job. What's the derivative? 2x dx. Okay, so we have x dx. We don't have a 2, so divide by 2, both sides. So 1/2 du is x dx. Okay, so that will be y equal to 0 to 2, x equal to 0 to square root 2 minus y. So we can have 1/2 du as x dx. So we have e to the x squared, right? Yeah, du. Just dx. Yeah, let's do it. Okay, now y equal to 0, 2, y equal to 2. And okay, so I made a mistake again here. I don't know why. Today I make a lot of mistake. So I should not be here, right? Because we have already integrate, right? So 1/2 e to the u du equal to 1/2 e to the u plus c. What's the u? 1/2 e to the x squared plus c, right? Okay. All right. So then we do evaluate from 0 to square root of 2 minus y. All right, so that would be 1/2 e to the square root to 2 minus y squared minus e to the 0, right? Okay, dy. All right, so that would be y equal to 0 to 2. Then 1/2 e to the 2 minus y minus 1. Yep, dy. Okay, let's integrate to respect to y. So there will be 1/2. So we want to integrate. So using this method, dy. So we just simply insert to the negative, right? Because by using chain rule, right? So that would be negative e to the 2 negative y plus c, right? Okay, otherwise, you sub, let u equal to 2 minus y. What's the derivative? Negative dy, right? Okay, so that would be negative e to the 2 minus y. Okay, let's factor out the 1/2. Then, so that will be negative. And integrate to respect to y. So negative y, right? And then we want to evaluate from 0 to 2. Okay, so there will be 1/2 negative e 2 minus 2 minus 2. Okay, minus negative e to the 2 minus 0 minus 0. Yep. Okay. So what do you get? So 1/2 negative e to the 0 power minus 2 minus minus positive e to the 2. Yeah. Okay, so 1/2 negative 1 minus 2 plus e to the second power. So we get 1/2 negative 3 plus e to the second power, right? Okay, we finish. Oh, finish. Okay, thank you for watching. You have nice evening or nice day. This is evening time. Good night. Bye. See you.